everybody, and welcome to episode 5 of Let's Play Kerbal Space Program. We are back on the launch pad with Pan Fried, a ship we designed for doing a flyby of Mun. It turns out it was capable of reaching orbit and returning safely from the orbit of Mun. Which means, for anyone who is experts in this game, like I am, they know if you can orbit Moon, then you can orbit Minmas, because although it takes a little bit more delta V being a measurement of how far your rocket can realistically go, although it takes more of delta V to reach Minmas, it takes significantly less delta V to establish an orbit and leave an orbit of Minmas. In fact, with any luck at all, we might be able to land on Minmas. Wouldn't that be crazy? I'm going to go ahead and start the timer. And we are going to be on our way to Minmas once again. Or not once again. Now, what would be ideal is if I waited until the evening. So what I want to do is wait till about here-ish, or a little bit more. So you can see that Minmas, its orbital inclination is not on the ecliptic. The ecliptic plane is the plane that the planet rotates, so that the sun goes around it. That's called the ecliptic plane. Minmas is off by a few degrees. To minimize the amount of futzing around I need to do to get myself on the same ecliptic, what I've done is fast forwarded to a point where my launch site basically crosses the plane that Minmas is on. And we're going to just launch so that our rocket is pointed a little bit north. Jebediah is in the pilot seat this time. 3, 2, 1, go! Up we go. We go straight up until about 50 meters per second. Standard launch procedure. Start kicking it over, and just the slightest little bit of down, like so. Just like that. T, turn off SAS, we'll let gravity do its job, and we'll see how close to an orbit, that orbital plane we got with Minmas. But I think that's going to be pretty good. Well, I'm going to pull it this way a smidge more. Pull it that way a little more. I think I got a little aggressive. The more I get this done now, the less it's going to cost me later. I think we'll have to go with that. As good as it's going to get. Yes, that is very true. It's been pretty much 6 months since I've played Kerbal Space Program. But I am excited to do it now. If you've been subbing to my channel, you know that I also have Portal Knights episodes coming out. Boom! Full throttle! Boom! We are officially on our way. This is a rather shallow ascent, though. But you know what? We'll have to, it'll work. I hope it'll work. We're going to find out if it's going to work. Jebediah Kerman in the pilot seat. We go screaming up towards Minmas. We're going to be getting an atmospheric drag here. Well, we're above 35. So, hopefully, it'll be alright. Hopefully I don't lose too much velocity. Hopefully I don't overheat. Go full prograde there, Jeb. Don't mind the atmospheric effects. Everything's fine. Really. Everything's going to be just hunky-dory. Aiming once again for a 75-kilometer apoapsis. 1, 2, 3, 4, 5. We know we're going to lose a significant portion of that as we climb up out of the atmosphere here, but such is the price of doing science. Let's go ahead and just fast forward. Got battery life to spare. That's not an issue. Getting to Minmas, one of the aspects of getting to Minmas is a little bit more tricky than reaching Moon, because its gravity well is so small. I have messed everything up with that. It's all bad. I need to do some drastic maneuvering. Wrong way. Drastic maneuvering time. So yeah, Minmas's gravity well is really, really small. So the bigger the gravity well, essentially the bigger the gravity well, the more gravitational influence a planetary body has, or a lunar body has, the larger a target you have to hit. Nothing like a little bit of vector in thrust to really strange things out. Derp. Okay. T. Prograde. Let's get our periapsis fixed. Luckily, we haven't lost much. Takes very little to get this periapsis to where it needs to be. And that's good enough for me. Okay, now zoom out. Set Minmas as our target. And how'd we do? We were off by 5.4 degrees orbital inclination. Looks like. But we did better than ecliptic. Yeah, the ecliptic, which is awesome. Now the same trick applies for going to Minmas as does going to Moon. Basically, you want to launch when it's over the horizon. So right about here. But first, we need to do a plane change fix. So we're going to face the descending node. We need to face north. Unless I'm completely off my rocker, that's this way. Hooray! I successfully navigated the 8-ball. So this is going to be what's referred to as a plane change maneuver, where we change the tilt of this orbital plane to match that of Minmas. And we're going to do that at the descending node. And it really doesn't take much. I want to get that as close to 0 as I can. Now we are in a position to plan our escape, our thrust to reach Minmas. Doodle doodle doot doot. Doodle doodle doot doot. Set this velocity to just barely kiss that orbit. Come down here. Trim this to just barely reach it. And that is a Minmas encounter. So now we can face this orbit node, this maneuver node, and get set for our Minmas injection burn. Estimated burn of 30 seconds. We know we don't have 30 seconds of fuel in this engine. In fact, we're going to be down to this engine. So, go ahead and warp to this maneuver. And we are on our way in episode 5 to Minmas. Or at least Minmas orbit. Or at the very least a Minmas flyby. Okay, I'm going to go ahead and initiate this burn at T-minus 30 seconds. Because I know the other engine has to burn extra long, since it's much weaker. Everything is all set. We are just barely on the light side of the planet, so we go ahead and do the burn from here. 4, 3, 2, 1, full throttle go. The tank is empty. Stage it. Enable the engine. A little bit of thrust. Full throttle go. So this is a 51-second burn. And once again, we can run the calculation. Phone? Where did I... Oh, there you are. In the old calculator, 150 divided by 1.6. Gives me 93 seconds of fuel. And we only have 20 seconds or so left to burn on this burn. It's going quite quickly. And you can see our apoapsis is growing very fast now. Okay, now we're going to go ahead and I'm just going to face prograde, get rid of the maneuver, I don't need it anymore, and we will just watch as this encounter hits Minmas with very little thrust. Minmas periapsis. And we can dial this in to minimize that periapsis. 50 kilometers is pretty good. We'll make other adjustments when we reach Minmas orbit. All right. Warp here. Departure angle on the viewer. Goodbye, Kerbal. There goes the moon orbiting around. I need to focus on Minmas. Focus view. No, I don't. I want to focus on me. Warp to the encounter. Keep our fuel gauge up. Because like I said, we're going to do a calculation once we get here. Okay. We are now under Minmas's sphere of influence. The periapsis of 50 meters, 50 kilometers. We're going to roll this around to a more useful angle. Do I want to roll around this way? Yes. So this is a plane change once again. And as you can see, since we're so far away from Minmas, it is... We can change this plane very, very quickly with very little thrust applied. About like that. Now we can trim up the periapsis. And I'm going to do that with thrusting radial in, which is this marker right here. Yes, Tabsy says it's a damn nice orbital insertion. Yes, it turned out really good. I'll aim for 20 kilometers. Actually, I'll aim lower, 15. Now, focus in on Minmas. It's a little icy ball of something. We don't know what. Let's do some math. On my phone calculator, which shows up backwards to you guys because I have my camera reversed. But anyway, 96.6 divided by 1.6 gives us 60 seconds of fuel. So in 60 seconds of fuel, we need to be able to orbit. If we want to do an orbit, we need to be able to establish an orbit, circularize our orbit, and then get our departure burn done in less than 60 seconds worth of fuel. So basically, whatever this is, times 2. There's a minimal orbit, 5 seconds of fuel used, so 10 seconds total between getting there and getting out. Dropping the apoapsis to a reasonable height, 12 kilometers, an essentially circular orbit, which I have somehow messed up. Oh, weird. The maneuver was still there, it just vanished or something. So there is our circularized orbit in 8 seconds. So that's going to be 8 seconds in, 8 seconds out. We might be landing. We might be landing. But before we get carried too far away, let's do some things. Like get a crew report. Crew report while in space high over Minmas. The lake beds seem relatively flat. Perhaps we could land there. Yes, Tabsy thinks I can do a landing. I'm thinking I'm going to attempt it. We'll take this data, do an EVA report. EVA report while in space high over Minmas. We record our observations as usual. Okay, let's face our maneuver. That's the thing about such a low gravity. It's a hard target to hit, but if you hit that target, you can do some pretty cool stuff. Let's warp here. And we can watch Minmas' arrival. Zoom. Here it is. Minmas in all its tiny icy glory. I can go ahead and warp to this maneuver. It's this is one of my favorite musical pieces. It's perfect for Minmas, actually. So, aim in the right direction. Since this is only an 8-second burn, I'm going to go ahead and start at T-8 at 50% throttle. It'll be a little bit easier for me to control. Oops. We're officially in orbit. There we go. And how do we do? 14 by 14. Wow. 14.2 by 14.9. We're in orbit, and we have all sorts of science to do. Crew report. Crew report while in space near Minmas. Looking at the surface of Minmas reminds you of a favorite childhood dessert. You are tempted to taste the surface. Keep that data. EVA report. Take all this data. Keep that experiment and store all that data back on Minmas or on the thing. Here's the question. The question is this. Do you get the materials-based study now? You know what? If we're going to attempt a landing, we should do the materials-based study on the actual surface when we land. So the first thing we're going to do is survey the entire, as much of these biomes as we can. Minmas orbits. Oh, we're going. Oops. Well, I missed some biomes. We're actually going antigrade. Our orbit is an antigrade orbit. Oh well. Quick, let's get this lake bed. EVA. Boop. EVA report. Minmas's lesser flats. And I want to get over this plateau. There. From space just above the lowlands. This dark patch looks like something slightly different. Different enough to take a look at. Yep. Yep. EVA. EVA report from the highlands. And this was a lake bed that we already did. And I can't quite see back here. Funky icy ball. Holy crap, that's a tall ass mountain. Well, let's check it out. That is a very tall mountain, from what I can see. Since the gravity is so low around Minmas, orbits are really slow as well. Like, I mean, you're barely moving. Let's do an EVA right here. This is the highlands. We already have the highlands, but that's okay. Okay, now we are going to plan. So we know we need to get out, we need 8 seconds of fuel. So another way to calculate that is we know that we need 8 seconds. 8 times 1.6. We need at least 12.8 units of liquid fuel. Ooh, we got a message. First flyby, first orbit, first spacewalk in orbit. Yes. 12.8. A descent burn looks like this. Aim for the lake bed. Takes 1 second, so add 1.6. And again, so we need 16 units of fuel to get up. Now the other question is, how much do we need to land? This is to arrest our velocity entirely. Doesn't say. Doesn't tell us. Delta V, it tells us our delta V, but it doesn't tell, oh, hello. 22, I can't rely on that. Well, you know what? Here's what we're going to do. We're going to quick save. That's what we're going to do. We're going to quick save. We'll get facing the right marker. And we're going to do the burn. To put us down on this mountainous region. There's more light. About there. Now, this maneuver. Right here. Whoop. 9 seconds. Plus. Well, it's 16, clear. 9 times 1.6 times 2. 28.8 plus 16 for all the escapes and stuff like that. 44. We totally have enough. We have 81. Okay, wait, hang on. 9 times 2. Plus essentially 9 seconds. 27 seconds total fuel. 27 seconds total fuel times 1.6 fuel per second is 43.2 fuel. We have 81 fuel, and yes, Tabsy is correct. We are going to land on Minmas before the moon. How do you like them apples? Put that maneuver right there. Hello everybody, this is Abraham, Chief Video Officer for Kerbal Space Program. This episode has run awfully long and we've decided to split it in multiple parts. Please check out the next part, which should be available soon. Touchdown any moment. What happened?